Hey, hi everyone, welcome back to this video series on Windows Server 2016 hardening and security. $3.5 million is the average cost to a business when they are the victim of a data breach. I recently heard this and other scary statistics at a Microsoft conference in Redmond. Some other statistics that can be used in order to get approval for an increase in your security budget. The average number of days an attacker resides in your network before detection is 243. That is the better part of a year, and they can camp out before doing anything malicious. What are they typically doing during those 243 days? Siphoning all of your data bit by bit out the back door. Another number is 76%, as in the percentage of network intrusions that happen as a result of compromised user credentials. Furthermore, it is becoming more and more difficult to identify these attacks in the first place because attackers are using legitimate IT tools in order to grab what they want. Why use malware when you can use something that is trusted and is going to fly under the radar of intrusion detection systems? Data security, network security, credential security, these things are all becoming harder to accomplish, but there are always new tools and technology coming out that can help you fight off the bad guys. Windows Server 2016 is the most secure operating system that Microsoft has produced. Let's discuss some of the functionality included that makes that statement true. Windows Defender, Windows Firewall, no laughing matter, encryption technologies, advanced threat analytics, general security best practices. Windows Defender, I have to say that I've been waiting for this one for quite some time. Anti-malware platforms have always been such a pain in the neck to deal with, but starting with Windows 8, we finally received a good alternative to the expensive memory hog third-party applications, at least on the client side. Windows Defender may not be the best thing since sliced bread, but it has one huge benefit over all other antivirus platforms. It is built into the Windows operating system. To my great disappointment, this built-in malware protection did not mirror over to the Windows Server side with either 2012 or 2012 or 2. Patience has paid off, however, and now in Server 2016, we have Windows Defender installed and running on our server operating systems. I can't tell you how many times I've tracked memory leaks and random server reboots to a poorly functioning antivirus software, which is unacceptable in today's server world. Even if Windows Defender might not have all of the bells and whistles that some of the third-party products have, it is anti-malware software and it is built into the operating system. This means it is going to integrate better than any software-based antivirus that you can try to install and should easily coexist with the operating system, resulting in fewer problems down the road. Updates are also simple as they come down via Windows Update. Like I said, I'm excited about the prospect of automatically having all my new servers protected against viruses right out of the box. Installing Windows Defender. Windows Defender is installed by default in Windows Server 2016. However, the graphical user interface may not be available depending on what specific SKU of Server 2016 you have installed. If you do not see a configuration console for Windows Defender, you can easily add the Windows Defender feature either from Add Roles and Features Wizard or by using the PowerShell CMD LET. Install Windows feature, name Windows Defender GUI. Exploring the user interface. The interface for Windows Defender is the same as within Windows 10. But if you haven't explored that yet, we'll take a quick look at it here, go ahead and launch settings from inside the start menu and then click on Update and Security. Once inside that section, you will see Windows Defender listed on the left. Here you have some quick options for enabling or disabling the active scanning that Defender does, but no advanced options for any further configurations. Near the top of the settings screen, you will see a link that allows you to open Windows Defender. Go ahead and click on that now. Now this looks familiar. As you can see, my definition files are a little out of date, probably because I don't have Windows updates enabled on this server, and that is the mechanism which pulls down Windows Defender updates as well. That is an important note actually. In order for Defender to get its new definition updates, you will want to make sure that Windows updates are also configured to be running on your server. I know many server administrators that choose not to install Windows updates on their servers very often in order to minimize reboots and changes. But running your server 2016 with this mentality will have some adverse side effects, such as your Defender updates not getting installed either. So here's what Windows Defender looks like. Disabling Windows Defender. It is important to note that Windows Defender is enabled by default, even though the GUI is only installed by default on some of the server 2016 SKUs. If you want to disable Defender, you must remove the feature from Windows. This is most easily done via PowerShell with the following command: uninstall Windows feature, name Windows Defender feature, Windows Firewall. When we think of securing our devices at the network level, we think of perimeters. Those perimeters are defined by and protected by firewalls, mostly at a hardware level with a specialized networking device made to handle that particular task in our networks. Today, we are here to talk about another layer of firewalling that you can and should be utilizing in your environments. Yes, we are talking about the Windows Firewall. It is easy to poke fun at the Windows Firewall based on its history. In the days of Windows XP and Server 2003, it was pretty useless and caused way more headaches than it solved. In fact, these feelings were so common that I still today find many companies who completely disable the Windows Firewall on all of their domain joint systems as a matter of default policy. If you ask them, there is usually no specific reason they are doing this. It's always been this way, or it is our written security policy. Our standard replies, this is a problem because the Windows Firewall with Advanced Security, WFAS, that exists in Windows operating systems of today is much more robust and advanced than ever before and can absolutely be used to enhance your security architecture. I would go as far as to say that it is entirely silly to disable WFAS on a current operating system unless you have a very good reason and very specific reason to do so. To Windows Firewall Administrative Console. First, it is important to know that there are two different consoles from which you can configure Windows Firewall settings, and one is much more capable than the other. Windows Firewall settings, opening up the control panel and navigating to system and security. Windows Firewall will get you a basic layout of what is going on with the built-in firewall in Windows Server 2016. You can see whether or not the firewall is turned on and some current status information. You also have the ability here to disable the firewall or to do something simple like allow a particular application to have access through the Windows Firewall. Windows Firewall with Advanced Security. If you're anything like me, you won't be satisfied with this information and will want to see what is going on under the hood with this thing, and you will still want a little more information than the Windows Firewall tool alone can give you. You can either click on the advanced settings link shown in the previous screenshot, or simply open a command prompt or a start run prompt and type wf.msc. Either of these functions will launch the full Windows Firewall with Advanced Security WFAS Administration Console. Here you can see much more in-depth information about the activity and rules that are in play with the Windows Firewall, and make more acute adjustments in your allowances and blocks. There is also a monitoring section where you can view actively engaged rules, including connection security rules. This is an important section because it highlights the fact that WFAS does much more than block network traffic. It is not only a firewall, it is also a connectivity platform. If you plan to utilize IPsec for encryption of network traffic, whether it be native IPsec inside your network or through the remote access technology direct access, you will see rules populated in this section that are definitions of those IPsec tunnels. The Windows Firewall is actually responsible for making those encrypted connections and tunnels happen. This is way more advanced than the Windows Firewall of the past. 3 different firewall profiles. When any NIC on a server is connected to a network, the Windows Firewall will assign that connection one of the 3 different profiles. You have probably interacted with this decision-making process before without even realizing it. When you connect your laptop to Wi-Fi at your local coffee shop, did Windows prompt and ask you if you were connecting to a home, work, or public network? This is your Windows Firewall asking you which profile you would like to assign to the new network connection. The reason that you can assign NICs and network connections to different firewall profiles is that you can assign different access rules and criteria for what is or is not allowed over those different profiles. For example, when your laptop is connected to the corporate network, you can probably be a little bit more lax than when the same laptop is connected at a hotel down the street. By assigning more intense firewall rules to the profile that is active when you're in the hotel, you build bigger walls for attackers to face when you are out walking on that public internet. Let's take a look at 3 different types of profiles that are available with a quick description of each. Domain profile. This is the only one that you cannot choose to assign. The domain profile is only active when you are a domain joined computer that is currently connected to a network where a domain controller for your domain is accessible. So for any corporate machine inside the corporate network, you can expect that the domain profile will be active. Private profile. When connecting to a new network and you are prompted to choose where you are connected, if you choose either home or work, that connection will be assigned the private profile. Public profile. When prompted, if you choose public, then of course you are assigned the public firewall profile. Also, if you are not prompted for some reason, or if you do not choose an option at all and simply close that window, which is asking you what to assign to your new connection, this public profile will be the default profile that is given to any connections which do not have different profile already assigned. Because each network connection gets assigned to its own profile definition, you could certainly have more than one firewall profile active at the same time on the same system. For example, my RA1 server is connected to both the corporate network as well as the public internet. Inside WFAS, you can see that both the domain profile and the public profile are active. Alternatively, if you open up network and sharing center on this server, we can also see the profiles listed here, and you can easily tell which NIC is using which profile. Building a new inbound rule. Now we know that the real meat and potatoes of the Windows Firewall is inside the WFAS console. So let's use WFAS to build ourselves a new role. On this RA1 server, I have enabled RDP access so that I can more easily manage this server from my desk. However, by turning on RDP1, I have now allowed RDP access from all other networks on this server. That means I can RDP into RA1 from inside the network, but I can also RDP into RA1 from the internet. This is a big problem because now any Yahoo on the internet could potentially find my server, find the RDP login prompt, and try to brute force their way into RA1. To alleviate this problem, I want to squash RDP only on my external NIC. I want it to remain active on the inside so that I can continue to access the server. But is there an easy way inside WFAS to create a firewall rule which blocks RDP access only from the outside? Yes, there is certainly. Open up wf.msc in order to launch the Windows Firewall with advanced security and navigate to the inbound rules section, and you will see all of the existing inbound firewall rules that exist on the server. Right click on inbound rules and choose new rule. This launches a wizard from which we will create our new firewall rule. The first screen is where we identify what kind of rule we want to create. We can create a rule that modifies traffic for a particular program, or you can look through the list of predefined protocols. However, I like knowing exactly what my rule is doing because of the way I defined it, not because of a pre-existing protocol definition. And I know that RDP runs over TCP port 3389. So I'm going to choose port on this screen, and after I click on next, I will define 3389 as a specific port which I want to modify. Our third step is decide whether we want to allow or block this particular port. There is a third option listed about only allowing the connection if it is authorized by IPsec, which is a powerful option, but necessitates having IPsec established within our network already. Because of that requirement, this option doesn't apply to most people. For our example, we already have RDP working, but we want to block it on one of the NICs. So I'm going to choose block the connection. We don't want to block RDP for all of our NICs though. So this next screen is very important. Here we need to reference back to our knowledge about those firewall profiles we talked about. Remember that internal NICs connected to our domain network will have the domain profile assigned to them, but any NICs that are not connected to an internal network where a domain controller resides will have either public or private profiles active. That is the knowledge we need to employ on this screen. If we want to disable RDP only on the external NIC, we need this rule to be active for only the private and public profiles. In fact, in looking back at the screenshots we already took, we can see that the external NIC is assigned the public profile specifically. And so we could check only the public box here, and RDP would then be blocked on the external NIC. But in case we add more NICs to the server in the future over which we want to make sure RDP access is not possible. We will leave both public and private checked to ensure better security for the future. Make sure that you uncheck domain, otherwise you will block RDP access to the entire server. And if you are currently using RDP in order to connect to this server, you will kick yourself out of it and be unable to connect. And now we simply create a name for our new rule and we're done. Our ability to RDP into this server from the internet has immediately been disabled and we can rest much easier tonight. How to build a rule for ICMP. Very often I find myself needing to create either an allow or block rule for ICMP. In other words, I often find myself needing to adjust the firewall on servers in order to enable or disable their ability to reply to ping requests. You must have noticed with newer server operating systems that this is pretty normal for the firewall to automatically block pings ICMP out of the box. When we need to create a new rule that allows pings to happen, we set up a rule just like we did for RDP, but there is one big catch. On that very first rule type screen, when creating a new rule where you have to identify what kind of rule you are creating, there are no definitions for ICMP. I find this strange because this is a very common type of rule to put into place, but choosing ICMP from the drop-down menu list would just be too easy. Instead, what you need to do is create an incoming rule that is configured for something else and then modify that rule. Let's walk through that together. Go ahead and create a rule similar to the way we did a minute ago for RDP. Create a new rule and tell it to use TCP port 3389, but this time define it as an allow rule and not be active on all of the firewall profiles. Or if you intend to only allow ICMP on certain profiles, then certainly go ahead and choose whichever ones are appropriate for your situation. Then on the last screen, when you type a name for this new rule, make sure to make it something about pings or ICMP so that you can easily identify it in the list of rules later. Once your new rule is created, what is currently doing is allowing TCP 3389 for RDP access, even though this is redundant because we are already allowing RDP. Now find your new rule in the inbound rules, right click on it and head into properties. As you can see here. Now navigate into the protocols and ports tab and expand the drop down menu for protocol type. Now you can see an option for ICMP as the protocol. Go ahead and choose appropriately for your network ICMPv4 or ICMPv6. There now. Since my internal network is all IPv4 based, I'm going to choose ICMPv4. After clicking on it, the new rule that was originally created for RDP access has now been changed to be an allow rule for ICMPv4, and this server will now respond to ping requests successfully. While this feels sort of a goofy way to create a simple rule, it's the most efficient way I have found so far. Sometimes you need to dig into the more expensive properties of a rule in order to make it do what you want. While you are in those properties, feel free to poke around a little and see what other options you have available to you. For example, we discussed you can determine what firewall profiles at a particular rule applies to, but what if you wanted to make the rule even more specific? If you look at the scope tab inside the properties of a certain rule, you can see You could even identify particular IP addresses or subnets and make it so that your rule only applies to traffic that comes or goes to specific networking information such as this. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.